Hypothesis testing in market research. This lesson teaches you how to use real customer datasets and hypothesis tests to make better business decisions. We focus on comparing customer groups, testing marketing campaigns, and understanding key drivers of satisfaction. Hypothesis testing helps you turn raw survey or behavior data into actionable business recommendations. You will analyze satisfaction surveys and campaign results step by step, using Python and real-world datasets. Running the cell now. We import pandas for working with tabular customer data. We import NumPy for numerical calculations and random seed control. We import OpenML to load public benchmark datasets for real market analytics. We use Seaborn for attractive and informative visualizations. We use Matplotlib for basic plotting tasks. We import scipy.stats for hypothesis test tools like t-test and chi-square tests. We import warnings to suppress noisy output and keep results clear. Warnings are filtered out so you can focus on insights and results. Running the cell now. Market research hypothesis testing: what, why, and how. In market research, a hypothesis is a business guess about differences or patterns among customers. Survey data includes demographic facts, satisfaction ratings, and customer choices. Each survey row is a customer and columns describe who they are and what they think or do. Beginners often misuse Likert scales as numbers or forget to check group sample sizes. Always check for missing values, data type mismatches, and survey weighting before starting your analysis. Running the cell now. We are going to use a real customer satisfaction survey dataset. We load the dataset directly from OpenML for authentic analysis. We transform it to a pandas data frame for easier manipulation. We print the number of rows and columns so you can see the dataset size. We preview the first 3 customer records to understand the data structure. Running the cell now. Here, we loaded the customer satisfaction survey dataset containing 7,043 customers and 20 columns of demographic and service-related information. Notice the mix of categorical variables like gender and contract type, alongside numeric columns like monthly charges, which indicates we must handle different data types carefully in hypothesis testing. This initial exploration helps ensure we understand the dataset structure before checking for missing values or mismatches, critical first steps in sound market research analysis. Try printing different slices of the data, such as df_cs.tail3, to see more of its structure. Before analyzing, it is crucial to understand where survey data is incomplete. We count missing values in each column. We print out which columns have missing data. This helps us avoid mistakes during hypothesis testing. Running the cell now. The output shows no missing values in any survey response column, which means our dataset is complete and ready for analysis. This check is crucial in market research to ensure that hypothesis tests are based on full, reliable data without gaps that could bias results. Always start by verifying data completeness to maintain the integrity of your findings. One business question is, what fraction of customers churned versus retained? We count each value in the churn column. We print the breakdown, helping a marketer see attrition patterns. Knowing this is key for formulating a business hypothesis. Running the cell now. This output shows the count of customers who have churned a yes versus those who have not, no. Notice there are significantly more customers who stayed, 5174, than churned, 1869, highlighting an important imbalance in the dataset. Understanding this customer distribution is key for hypothesis testing because it ensures we consider group sizes when comparing behaviors or satisfaction between churned and retained customers. Let us explore, does observed churn differ by customer gender? We use Seaborn's count plot to compare churn for men and women. The title makes the purpose easy to understand for stakeholders. We label the x-axis for customer gender. We label the y-axis so counts are clear. The plot is shown to highlight differences visually. Running the cell now. This count plot shows the number of customers who churned or stayed, broken down by gender. Notice the relative heights of the bars within each gender group, which reveal if one gender has a higher churn rate, a key insight for testing hypotheses about customer behavior. This visualization helps confirm sample sizes and group differences before conducting formal hypothesis tests. A classic beginner hypothesis: is churn rate the same for men and women? We build a contingency table that counts churn per gender. We run a chi-square test of independence, a standard tool for this question. We print the test statistic, which measures the difference. We print the p-value. A small p-value means a difference worth investigating. Running the cell now. This output shows the results of a chi-square test comparing churn rates between genders. Notice the p-value is high, 0.49, indicating no significant difference in churn by gender in this sample. This connects to the lesson by highlighting the importance of checking group comparisons properly rather than assuming differences, reinforcing sound hypothesis testing in market research. What if you used a different column, such as a partner, instead of gender? Try it! Does average monthly charge differ between churned and retained customers? We split the monthly charges into churned and not. We perform a two-sample t-test to compare the means. We print the test statistic, the difference strength. We print the p-value for business interpretation. We print the average monthly charge for churned customers. We print the average for those who did not churn. Running the cell now. This output reveals a highly significant difference in average monthly charges between customers who churned and those who stayed, with churned customers paying notably more on average. The extremely low p-value confirms this difference is unlikely due to chance, demonstrating the value of hypothesis testing in identifying key customer patterns. Notice how verifying group means and test results helps avoid misinterpreting numeric survey data, a crucial step in market research analysis. Now we analyze a real marketing campaign performance dataset. We load the OpenML Bank marketing dataset for customer response analysis. We convert it to a pandas data frame for manipulation. We rename the columns using clear marketing terms. We print its dimensions to check the size. We preview key columns for quick business sense checking. Running the cell now. This output shows the dataset has 45,211 customers and 17 columns, confirming a large sample size for reliable analysis. The first three rows reveal key variables: customer response, 1 equals positive, job type, and age, illustrating typical columns used to explore patterns in customer behavior and test hypotheses in market research. Notice how the response column is binary, which is important for segmenting customers based on their reactions to the campaign. A typical campaign question is, which education group converts most? We compute conversion rates using crosstabulation. We print the result for business optimization. Now you can spot which education level is more responsive. Running the cell now. This output shows the proportion of customers who responded 1 or 2 across different education levels, highlighting conversion rates normalized within each group. Notice how the highest conversion, response equals 1, rate occurs with primary education and decreases with higher education levels. This helps us understand group differences and reminds us why checking sample sizes by category is crucial before making market research conclusions. Try this with job title or group age values into buckets for more insights. A deeper hypothesis: do customers with primary or tertiary education respond differently? We encode campaign responses as 0 and 1 for both groups. The groups are separated for statistical comparison. We apply a t-test to see if average response rates differ. We print the t-statistic and p-value for decision-making. Running the cell now. The output shows NaN for both the t-statistic and p-value, indicating the test couldn't compute results. This likely means one or both groups have no variation or missing data in their response variables, highlighting the importance of checking group sample sizes and data quality before hypothesis testing. Without proper data preparation, statistical tests like t-tests won't produce meaningful results. Visualizing customer age for those who responded and those who did not helped spot campaign targeting opportunities. We plot the distribution of age for responders in green. We plot non-responders in red. Both groups appear in one chart with labels for comparison. The plot title explains its use for business review. We label axes for age and group size. The final plot reveals any visually observable age pattern. Running the cell now. This plot shows the age distribution of customers who responded versus those who did not respond to the campaign, with green representing responders and red for non-responders. Notice the shape and overlap of the two distributions, which helps us understand if age influences response behavior, a critical step before testing hypotheses about group differences. This visualization also highlights the importance of checking sample size across groups, ensuring our comparisons are valid. Can you see a particular age segment where response is higher? Segmentation is a key market research tool to test campaign effect by customer age group. We categorize age values using business-relevant bins. We cross-tabulate response counts by age group. We apply chi-square to formally test for age-driven response differences. We print key test outputs for manager review. The final table shows patterns at a glance. Running the cell now. This output displays the distribution of campaign responses, 1 equals responded, 2 equals did not respond, across for age groups, highlighting that most customers fall in the 31 to 45 and 46 to 65 ranges. The very large chi-square statistic and near-zero p-value indicate a statistically significant difference in response rates by age group, confirming our hypothesis that age influences campaign effectiveness. Notice how checking group sizes here ensures valid inference, preventing misinterpretation when comparing customer segments. Now we simulate a Net Promoter Score survey to analyze customer loyalty hypotheses. We set a random seed for reproducibility so results remain consistent. We generate synthetic customer region and NPS ratings just like a real survey. We preview the structure of this loyalty-focused dataset. Running the cell now. This output shows the first 3 rows of a synthetic Net Promoter Score (NPS) survey dataset, where each row represents a unique customer with their age, region, and NPS rating from 0 to 10. Notice the diversity in ages and regions alongside varied NPS scores, reflecting how real survey data captures different customer segments and satisfaction levels. This preview confirms successful data loading and structure, crucial before exploring group differences or testing hypotheses in market research. A leadership-level question: does Net Promoter Score vary by geographic region? We compute the average NPS for each region. We apply a one-way ANOVA to test if the scores differ beyond random chance. We print the NPS regional averages for context. We print the ANOVA F statistic. We print the p-value for business decision significance. Running the cell now. This output shows the average Net Promoter Score (NPS) for each region, revealing slight differences in customer satisfaction across East, North, South, and West groups. The one-way ANOVA test results, an F statistic of about 1.29 and a p-value greater than 0.05, indicate these differences are not statistically significant, meaning we don't have strong evidence that region affects NPS in this sample. This highlights the importance of formal hypothesis testing to confirm whether observed group differences reflect real patterns or just natural data variability. Practice: how would you summarize these findings for regional business leaders? Segmenting promoters and detractors helps managers target loyalty-building programs. We group NPS scores into standard categories: detractor, passive, promoter. We also bucket age for business-relevant reporting. We create a table of the proportion of each NPS category per age group. We print this for actionable audience insights. Running the cell now. This output shows the proportion of NPS categories, detractor, passive, and promoter, within each age group, revealing key differences in customer sentiment by age. Notice that all age groups have more detractors than promoters, with the youngest group, 18 to 30, having the highest proportion of detractors. This helps us understand how customer satisfaction varies by demographic segment, emphasizing the importance of checking group proportions rather than raw counts before testing hypotheses. Do some regions have more promoters or detractors? We can answer with cross-tabulation and hypothesis testing. We create a contingency table of NPS categories by region. We run a chi-square test to check for differences in distributions. We print the table so managers can spot hotspots. We print the chi-square value for technical reference. We print the p-value for business decision relevance. Running the cell now. This output shows the count of customers in each NPS category, detractor, passive, and promoter, broken down by region, helping us see how customer sentiment varies geographically. The chi-square test then assesses if these differences are statistically significant. Here, the p-value above 0.05 suggests no strong evidence that NPS distribution differs by region. This step emphasizes the importance of checking group sizes and using appropriate tests to support or refute market hypotheses based on survey data. Business leaders often demand clean, interpretable results. We count and remove rows with missing NPS scores for cleaner testing. We drop NA values in the NPS_scores column. We print how many responses were removed and how many remain for robust analysis. Running the cell now. This output shows there were no missing NPS scores in the survey data, so all 500 customer responses remain for analysis. It highlights the importance of checking for missing values before hypothesis testing, ensuring your sample size is accurate and reliable. This step prevents errors from incomplete data affecting your market insights. One classic beginner mistake is ignoring sample size before group-based tests. We count survey responses per region to ensure reliable group tests. We print the group sizes so you can check for underrepresented segments. Balanced group sizes reduce the risk of misleading business conclusions. Running the cell now. This output shows the number of survey responses collected from each region, with counts ranging from 113 to 149. Noticing these group sizes is crucial before running hypothesis tests, as balanced or sufficiently large samples help ensure reliable comparisons across regions. This step highlights the lesson's emphasis on verifying group sample sizes to avoid invalid conclusions in market research analysis. Another common error is treating Likert attitudes as ratio numbers without caution. We create a fake Likert scale survey and map responses to numbers. We display the text-based answers. We display the numeric version. We print the mean, but always remind business users that averaging Likert data can be misleading. Running the cell now. This output shows how Likert scale responses are mapped to numeric scores from 1 to 5. Notice the categorical labels remain descriptive while their numeric encodings allow calculation of a mean, here about 2.87. The lesson highlights that treating ordinal Likert data as simple numbers can be misleading, so understanding its categorical nature and distribution is crucial for valid market research insights. Always check if group sizes and measurement scales suit the hypothesis test you are using. Segmentation helps managers target the right group with better offers or messages. We segment customers based on tenure into business-relevant bins. We display sample mappings to clarify the segmentation logic. Running the cell now. This output shows how the continuous tenure variable is segmented into meaningful groups labeled by customer tenure length, like less than 1 year and 2 to 4 years. Notice the grouping aligns with bins we specified to simplify patterns and comparisons across customer segments. This step is key to testing hypotheses about how tenure relates to customer behavior. Crosstabulation summarizes key relationships for managers and non-technical readers. We use Crosstab to compare churn rates against payment method. We print out the churn rate for each payment type so trends are easy to spot. The top of the table shows whether any payment method is associated with higher churn. Running the cell now. This output shows the churn rate grouped by payment method, revealing that customers using electronic checks have a notably higher churn rate, about 45%, compared to automatic payments. By normalizing within each payment group, the code helps us compare churn proportions fairly, emphasizing where retention issues might exist. This ties directly to the lesson's focus on exploring patterns in customer groups to inform targeted business hypotheses. You can also crosstab by contract type, service tier, or any customer attribute. Scores and indices help managers track abstract concepts like satisfaction with a single number. We pick several binary satisfaction indicators. We count the number of yes answers as a simple composite score. We summarize the score with a .describe call so executives understand score levels. Running the cell now. This output summarizes the new composite satisfaction score, which counts how many services each customer uses. Notice the score ranges from 0 to 3 with a median of 1, indicating many customers use one service, while fewer use all three. This helps us understand customer patterns and prepares us for hypothesis testing on satisfaction differences across groups. Trend analysis supports revenue growth by detecting patterns over time or over the customer life cycle. We compute the mean monthly charge for each tenure group. We plot the result as a bar chart for presentation clarity. The title helps everyone understand the key comparison. We label the grouping axis for readability. The y-axis tells managers about potential revenue per segment. The chart visualizes trends in customer spending. Running the cell now. This bar chart shows the average monthly charges segmented by customer tenure groups, highlighting how charges tend to change as customers stay longer. Notice any upward or downward trends, which can inform hypotheses about customer value over time. This step is crucial for testing if tenure impacts spending, ensuring we interpret differences across meaningful customer segments. Now we solve an end-to-end business problem using real data and hypothesis testing. We create a satisfaction score for each customer based on satisfaction indicators. We split customers by churn outcome for testing. We conduct a t-test to compare means for each segment. We print the mean satisfaction for churned customers. We print for retained customers to see any difference. We print the t-test statistic value. We print the p-value to determine if this is a real business effect. If p-value is less than 0.05, managers should address the satisfaction gap. Otherwise, other factors may drive churn. Aim to investigate further. Running the cell now. This output shows average satisfaction scores are lower among churned customers, 0.76, compared to retained ones, 1.03, highlighting a clear difference in satisfaction levels. The very small p-value confirms this difference is statistically significant, supporting our hypothesis that satisfaction relates to churn status. This step illustrates how hypothesis testing quantifies group differences to inform business decisions. Congratulations! You have run a complete hypothesis-driven market analysis. If you want to learn even more, there are many in-depth walkthroughs available on YouTube. We display a reminder to continue your learning journey with video guides. Running the cell now. This message reminds you to explore additional practical tutorials on YouTube to deepen your understanding of hypothesis testing in customer analytics. It's a prompt to supplement this lesson by seeing diverse examples, helping reinforce the core concepts like checking group sizes and proper data handling. This supports the lesson's intent to build confidence in applying hypothesis tests correctly using real survey data.